Hi, I'm Bill Berkey, president of Zebra Skimmers. I take a lot of tech calls, support calls, and I've probably talked to a number of you about skimmers, coalescers, sumps going sideways, you know, that Monday morning thing, coolant automation, and of course, mixers. Today, let's talk a bit more about coolant mixers and a couple of the most common issues we find with those mixers. And I'll also bring up the granddaddy of issues that I hear on those calls. First, a quick discussion about the types of mixers that we see. One is the pail. Everybody knows about the pail. Set it down, dump some coolant in it, add some water, carry it over to your sump, pour it in. The next type of mixer you're probably familiar with, it's a Venturi style mixer. Our mixers that are Venturi style, the economy mixer, the machinist mixers, they are based on the Venturi principle. Water pressure comes through a cavity, it creates a vacuum, it pulls coolant into the stream, discharges that out to your pail. How do you figure out what your water flow rate is? Well, check out this video.
How do you determine if you need a 3-gallon or a 10-gallon mixer? We have a simple solution for you. You take a regular hose and a 1-gallon container and you will fill it and time it. So that was 15 seconds.
And then there's proportioning pumps. Proportioning pumps are water motors. You need about 35 to 75 psi's of water pressure, water in one end, drop a hose into your coolant drum or tote, and you can plumb the other side. You can run that through your entire shop, run a hose to it, the whole thing. Venturi mixers, all the mixers are rated for certain types of coolant and coolant viscosities. And coolant viscosity is measured in SUS. So our Venturi mixers are rated for coolants up to 500 SUS. Okay, so let's talk about some issues we see with mixers. One is coolant concentration. Coolant concentration is measured in SUS units, which are Seybolt universal seconds. What's a Seybolt universal second? Well, that's the time in seconds for 60 milliliters of oil to flow through a standard orifice at a given temperature. Coolant is also measured in centistokes. You might find that. To get from centistokes to SUS, multiply the centistokes by 4.6 and you're there. There are some temperature differences, but for all intents and purposes, you'll be fine. Okay, so how do you determine the SUS viscosity of your coolant? That's a question I hear all the time. One, you can ask your coolant distributor. Then you can check the coolant technical data sheet. It might be on there, and you can also check on a barrel or drum. Oftentimes on the tag, it'll say what that correction factor is. Or you can use the quarter drop method. And thanks to our friends at Qualichem who sent coolants from various SUS ratings, you can do this.
To test the viscosity of your coolant, we're going to be doing a coin test. We will take a dime and drop it into each sample and see the rate of descent.
Okay, so tying this SUS rating back to mixers. Venturi mixers are really good for coolants less than 500 SUS. If the coolant gets too thick, there's not enough vacuum to draw that coolant into the incoming stream and output it to your pail. So that kind of gets us into issue 2. Now that you've got the viscosity figured out, you can say, well, I can't get to my concentration. Well, you have to consider the coolant correction factor. The coolant correction factor is a multiplier for the Brix reading you have on your refractometer. So if you're mixing your coolant, put a drop on your refractometer, take a look, and if it reads 5, you have to do something with that number, typically. Sometimes a coolant will have a correction factor of 1, then you're good, you've mixed to 5%. Sometimes a coolant can have 2, 3 or more as a correction factor. So if you're mixed to 5, You need to multiply it by 2 if you have your coolant correction factor is 2. So your actual concentration is 10%. So what I've seen in shops is that people don't know about the coolant correction factor. They mix to what they're reading on the refractometer and they're wasting coolant. So if your coolant correction factor is 2, you're actually using twice as much coolant than you need. But the granddaddy of issues I hear is, my mixer isn't working, I'm only getting water. 9 times out of 10, this is because somebody with a Venturi mixer has taken that 40-inch tube that we provide and added a hose or tried plumbing it throughout their shop. This absolutely will not work on a Venturi mixer. As we mentioned before, we're trying to push that stream across a cavity and it creates a vacuum that pulls the coolant into the stream of water. If there's too much back pressure, that vacuum collapses and all you're getting at the other end is water. So with Venturi mixers, please do not use anything other than the included 40-inch tube that comes with the machinist mixers and the tube that comes with the economy mixer. However, if you do want to plumb throughout your shop, use a proportioning pump. They're awesome. You can go up 25 feet, over 800 feet, and these are the heart of our Dazzle 1 automation system that you can find out here.
In order to properly cool and lubricate machined parts, coolant must be kept at optimal levels and concentrations. Having employees frequently check coolant levels, test concentrations, and manually add coolant and water via inefficient bucket brigades results in lost time, sump overflows, and expensive wasted materials. Not only overfilled and spilled coolant, but defective or out-of-spec parts if coolant levels fall below acceptable levels or concentrations. The Dazzle 1 by Zebra is an automated coolant delivery system that constantly monitors your coolant levels and then adds coolant and water at the appropriate concentration to fill coolant sumps as needed. Get rid of the bucket brigade hauling and dumping coolant manually and often wasting expensive coolant in the process. Eliminate the need for constant manual measurement and testing of coolant levels and concentrations. Reduce the wear and tear on your machinery and ensure the proper quality of produced parts and materials by automating the most critical part of your system, the coolant supply. Our system consists of the Dazzle pump, which precisely controls coolant makeup concentration and its delivery, which can reduce coolant costs up to 30%. The Dazzle dipstick, which continuously monitors coolant levels with visual and audible low-level alerts and reliably delivers neat coolant to the Dazzle pump. The Dazzle sump, a programmable controller that maintains sump levels at optimal field-defined set points to within centimeters, preventing overflows and putting an end to bucket brigades. The Zebra Dazzle 1 system is modular, easy to install, and adaptable to a wide variety of production environments.
Okay, thank you very much. If you have questions, please feel free to give me a call.